2, 1. Hello to everybody out there. I suppose there's just maybe one person in Russia following me right now. So we're got a little theme music here. I gotta turn the volume up, if I can figure out how to do that. Alrighty, here we go. It's by, and I got a little audio feedback. It's driving me nuts. It is by the Eurythmics. And you guys hear? Oh, maybe that wasn't the thing to do. I thought I was going to get some music. So, ooh, ouch. So that was Here Comes the Rain Again by the Eurythmics. So I thought about that this morning when it was raining and my dog was howling. So I've got my fancy little bow tie on. It's got the number 3. It was made with a 3D printer. So there is 2 calc students, Marcus Modashel, I think that's how you pronounce his name, Brian Call. Anybody in robotics in here? Jack, are you in robotics? No? You're not a robotician? You took robotics. Where'd you take it? You took it here? Oh, it's a class. Okay. So isn't there a robotics club? And you're not in that. No one's in there, huh? Oh, okay. So anyway, they made this for me. And it's hard to stay, but I'm thinking about it. I got a wedding on Saturday. That's how the other class reacted when I said that. I'm not in the wedding. It's my niece. And it's kind of a it's in Minnetonka, at Minnetonka Beach Club. So I think it's kind of hoity-toity. You know what I mean by hoity-toity? Okay. Not all of them are teachers. Some of them get paid more than teachers. And I thought this would be a great tie to have. I might fake it and have a different tie and then tell my wife I gotta go to the bathroom and then switch really quick. Because sometimes she wants me to ask permission. Alrighty. So we started this, correct? And Jack, did you have an opportunity to copy? Okay, it's also on the Abyss, or will be on the Abyss, what we did yesterday. Okay. Did we talk about removable and non-removable? Did we have anything here?
Yes.
Okay. Did I have this? Something like that? In other words, f of c is not defined. Correct? Is that one of them? And then did I have this? Here's C, here's L, here's f of c. Caitlin, did I have that one somewhere? Maybe not in this order. And so this is the limit. Well, I'll make it short for myself. The limit, right, which is L. You can see that, right? L is not equal to f of c. It's breaking one of these things up here, correct? Would everybody agree? And then I had one like this, I'm thinking. And this, the limit does not exist. I should probably write it this way. Did I have that? And so these are examples of discontinuity, correct? And then there's a fourth one. Denise, do you know what the fourth one is? I've got a jump, right? I got a couple of holes, right? Yes, God, you made me feel good. You didn't say I don't know. Okay? The problem with I don't know is if you truly didn't know, I'd be okay with it. What I don't like is when we use I don't know to participate. It'd be like when I asked Mitch is my youngest son, would you like $100? I don't know. Really? You don't have an opinion on that? I think it'd be different now. Okay. So here's an asymptote. The equation of the asymptote is x equals c, and so there's a graph. So in calculus, we would say the limit as x approaches c of f of x does not exist, and f of c is not defined. Right? 1 and 2 are broken, correct? They're not even there. Alrighty. So did I talk about removable at all? Okay, so did I have this one? Correct? And here's L, here's F of C, here's C, and then did I have this one? Oops, no I didn't. Shoot it, I didn't want to do that. Jack, I'm sorry about that. Thank you. That's removable, and I think what I want here is a jump of some sort, right? Is that correct?
You never talked about non-removable.
I didn't talk about this one?
No.
Did I talk about this at all?
Yeah, you talked about the two removable.
Okay, so the big thing is they're holes, correct? And so if I simply would say, hey, I'm going to redefine f of c and make it L, then this would be okay, correct? In other words, how do I fix this? I make f of c equal to L. That's how I fix it. This baby comes down, right? Over here, what do? I define f of c. That's how I fix it. I define f of c. What does that look like? Well, I shade it in, correct? Okay. Have I told you my coloring story? How I failed coloring? So I'm in kindergarten. Kindergarten was a tough year for me. Okay? And there are 9 kids in my kindergarten class, Landry. All right? The very last day of school, I think the kindergarten teacher wanted to get some stuff done, and so she had us do a coloring contest where we got a sheet of paper and we're supposed to color. And the best colorers would get a certificate. Now, this certificate was made out of cardboard. And it had kind of a tin goldish seal on it. It wasn't color. It was actually kind of metalish. So it was official. And it was signed by her, Mr. Buron, who was the principal, and somebody who I believed was the governor of Minnesota. Yeah, big deal. Okay? So, at the end of the coloring time, 8 of the 9 students got certificates. One little red-headed chubby fellow did not. And he went home crying to his dad. I didn't get a coloring award. And he said, you shouldn't have. You can't color. So you feel probably sorry for that little boy. But that little boy only used one crayon, black. And he didn't feel like he should be restricted by any boundaries. So he took his crayon and turned it sideways, ripped off the paper, and colored the thing in about 5 seconds and handed it in. He knew that at some time black would be a very popular color and didn't feel like he should be contained by any picture. I think that person just kind of saw the future. So anyway, this is a jump. And I can't shade this in because then it wouldn't be a function, would it? So there isn't any way to remove this. Here we can define f of x, define f of x as f of c. You know, color it in. Here, move it down. But here you can't do that. So this is just a little review. One-sided limits. The limit as x approaches c from the left of f of x we call a left-handed limit, which you should be okay with, right? I'm hoping, right? And the limit as x approaches c from the right of f of x is a right-sided one. Okay? So let's look at this function. F of x equals the square root of x. And Alexis, I'm so proud that this is like the 3rd time I've said your name and not screwed it up. What can you tell me about that limit?
It would be 0.
Okay, why would it be 0?
Because if you plug in 0, or even if you plug in 1.
But I'm not plugging in 1. Look at it carefully. It's tricky.
It's from the left.
Mm-hmm.
From the left.
Mm-hmm. What numbers are over there on the left-hand side?
-1.
Yeah, -1. Okay, let me plug a -1. What happens?
You would get a weird I number.
Yeah, we're not doing I in this. You're right. You're right. And we spend a great deal of time in pre-calc talking about I, and complex numbers, which we will talk about in calculus, but not in this class. I'm letting somebody else teach that. Okay, we're just trying to learn the basics of calculus. Multivariable people will deal with that. I'm not teaching multivariable calculus. So we're not dealing with I. Okay, so let me ask you again. What is the limit of that?
0.
No. No. It's a stumper, isn't it? But you know what I liked about our dialogue? You attempted to do it and you gave me a whole bunch of direction. Okay? Allison, what do you think?
Doesn't exist.
Does not exist. For the same reason that I think Alexis was thinking. What's the problem there? You can't put a negative number inside there, right? So coming from the left you can't do because it's not there. So Justin, what if we approached it from the other side? It would work, correct? So what is our limit then from the other side? Zero. And if we looked at the graph, this is the graph of the square root. It looks like this. it grows very slowly. Do you guys know what I mean by growing very slowly? Think about it. At 0, I'm at 0, correct? At 1, I'm at 1. But I have to get all the way to 4 to get to 2. I have to get all the way to 100 before I can get to 10, correct? It's not growing very fast, is it? Okay, and once you keep that, take that idea, not growing very fast, find a spot in your brain and tuck it in there for a little bit. I'll bring it back. Okay, not today, but somewhere in the future. Okay, next page. Step functions. There are different kinds of step functions. We're going to talk about this one that looks like this. And in your homework, they give you different ones. And so this one looks like this. Here's 1, here's 2, here's 3, and it's going to be shaded, and then here's 1. And it's called step functions because guess what? They look like steps. And it's discontinuous, isn't it? Right? There's a bunch of jumps. So, greatest integer function. Did you guys talk about the greatest integer function? The greatest integer function says, give me an integer. Integers are like ... -3, -2, -1, 0, 1, 2, 3, ... You got the pattern? Right? I put little set brackets because we're talking about a group of numbers. Those are integers, right? So it says, give me the greatest integer, n, such that n is less than the number you put in here. So Elijah, we got these, I don't know, I think Mr. Karsh's book's a little bit different, but we got these funky brackets. They look like double brackets. If I plug 2.5 in here, what do you get? What's the greatest integer that does not exceed 2.5? 2. Excellent. So 2.5 would be here, right? And then I'd mark it at 2. So I remember learning this as a senior in advanced math topics. And I remember Mr. Eckstein saying, Chuck, what would this be? So Elijah, what would that be? 2. And I go, oh, I get it. And so Mr. Eckstein said this. Which is way over here. What would that be? What? It's 2 also. I go, so you know what I did, Elijah? I said, this makes sense. I just drop off the decimal. It's a decimal remover. You know, like paint remover? Fingernail polish remover? So, then he said this. What would that be? I got it wrong and you got it right. Why is it a -3 and not a -2? We must spend 15 minutes second period talking about this. What do you think? You're stumped. See, being stumped is okay. So I'm going to ask Ryan, what do you think?
Has to be less than x. You can go down to the next.
So are you saying a -3 is less than a -2? And then a -2.5 is less than a -2? And that a -3 is less than a -2.5? Why?
It's farther away from 0.
Okay, let's go with that, because you are partially correct. It's farther away from 0, but why is 3 bigger than 2 when 3 is farther away than 0? See what I'm saying? So it's that interplay of language. You're thinking farther away in a particular direction, correct? So 2 is less than 3, correct? And negative 3 is less than negative 2, correct? And negative 3 is less than a positive 3 because on a number line, those numbers are all to the what? The smaller numbers are always to the left, correct? And so really what we're looking for is what is the greatest integer that's immediately to the left of that number that gets inputted in, wouldn't we? And so we get this graph. So Jack, if I were to continue into the negatives, here's a negative 1, okay? What would you have me do to continue this step function? Right here? On the y-axis, right here. So do I have a horizontal line?
X-axis, sorry.
Like that?
Yeah.
So let's take a look. If I got negative 0.5, it'd be a negative 1. Oh, am I wrong?
I don't think so.
Okay. If I got negative 0.5, I have a negative 1. A negative 0.1, I'll have a negative 1. If I have a negative 0.9, I'll have a negative 1. Correct? Would everybody agree with that? All right. So you have some problems to deal with this step function, as long as everybody understands that. Okay? Existence of a limit. Owen, what do I need to state for the existence of a limit? We spent 15 minutes on this second period also. We got a lot of I don't knows, which I found out is IDK. I didn't know that. Okay, so this is, seriously, this is a text. I sent a text to my son Mitch. He responds, IDK. And I write back, I don't know what IDK is. And then he puts LOL, which I thought was lots of love, which isn't. When I looked it up, I see people, you know, when somebody dies, you don't respond LOL. I've seen that chat line, okay? It means laugh out loud. Okay. All right. So anyway, how do I know there's an existence of a limit? Not sure?
Not sure.
Not sure. NS.
What? For the existence of a limit, you need a graph to start, right? You need a function.
You're making it more complicated than I want you to. Okay? We took a quiz, right?
Yeah.
Okay. And how did I say? I said, okay, find the limit and explain why it is. Why does the limit exist? You're okay. If you can't remember, that's fine. I'm going to ask Ty. Ty. What do you think? Yeah, I'm saying, what do we check to see the existence of a limit? And how do we approach that number? Okay, how do I write that? L. Limit as x approaches from what direction? Right, so I'm going to put a plus sign there on a function. What has to be true if there's an existence of a limit?
It has to like get smaller and smaller, or like they have to approach the same number,
From which direction?
both sides.
Okay, and I've got one. I've got the right side. What do I have to say that's equal to?
Limit as x approaches c from the left of f of x.
And there has to be the same number that I call L. Okay? Now, if I know that to be true, I have a limit. F of c does not need to exist, does it? Because it could be a hole. Holes and continuous functions have limits. Holes and continuous functions have limits. So if I know a function is continuous, I know it has a limit, and I can plug that number in to know what the limit is. It's the easiest way. For example, f of x equals x squared. That's a parabola, correct? Is it continuous? Yes. So if I want to know what the limit is as x approaches 3, all I have to do is plug 3 in and know that limit is 9. That's going to approach 9 as it approaches 3. And it's 9 if it approaches a negative 3. Correct? Everybody with me on that? That's all you need to say, and the limit exists. Holes and continuous. All right, definition on a closed interval. So let me show you a picture of a closed interval. Here's A, here's B. In calculus, we love the letters A and B. They're usually our symbols we use for an interval. If you don't like that, make it 1 and 3. And it's closed, so these are closed points. And I have something that looks like this. I made up that graph. So the domain is this. This is my domain. So Alexis, you were my sacrificial lamb. I apologize for that, okay? Because I used the square root of x. We can't approach A from the left, can we? Because it's not in the domain. So if we remove I, negative numbers are not part of the domain, okay? And we can't approach B from the right, because those numbers aren't in the domain either, right? Correct? Okay. So, the limit, Landry, as x approaches A from what direction?
Well, as x approaches A from the right.
Right, from the right of f of x. Well, if on my graph I call this f of A, and up here I call this f of b, right?
Yep.
In other words, how do I compute this y value? I plug A into it. How do I into the function f? How do I compute this y value? I plug b into the function f. Everybody understand that? Okay, it's easy now. You're going to goof up later on, I tell you. You're going to say, how did you get that number? Well, I plugged it into f, but you'll forget. So this limit has got to be what, Landry?
F of A.
Thank you.
Yep. Sorry.
And so, how am I going to approach B? From the
Negative.
left. It's not negative, it just means from the opposite side. Of f of x would equal f of b. You guys are being awesome, by the way. Thank you very much. All right. properties of continuity. So I'm going to have one property is called scalar multiplication. And what I'm going to do here, I'm going to say f and g are continuous functions. And A is a number. Now, a long time ago, the hashtag symbol used to mean number. Even before that, it meant pound. Now it means, I don't know, every time I tweet, I got to type in the hashtag. I don't get what that's for. Julie, I'm confused. Okay. So, it says if A times F is continuous. I'll give you an example, Julia. F equals x squared. A parabola. Continuous, correct? I could put any number I want in there. Anything. And everything's okie dokie. 2 times f would be 2x squared. Well, that would be continuous too, correct? That's what I mean by scalar multiplication. So this says, okay, if I added and subtracted, if both of these are continuous and I added and subtracted, it would be continuous. Like, let's say g is simply the function x. Well, wouldn't x squared plus x be continuous? Wouldn't be x squared minus x be continuous? Are there numbers that I can't put in there? Do I need to make this bigger?
No.
You sure?
He's on it,
Okay. 3. F times G is continuous. I'm going blank here. I can't even spelling though. Continuous. Such like, what do I get if I take x times x squared? Well, isn't that going to be x cubed? Isn't that continuous? Right? This would be f times g, or g times f, I guess. What else would be? 4. F over g. Now, Caitlin, division. We have issues with division. Why?
Forget. Not like, I don't know how to explain. Like most of the time, people when they are like dividing, they could like easily multiply by something in it.
Oh, the reciprocal?
Yeah.
Okay. Can I divide by anything I want? Can I just go haphazardly start dividing? No. Why not? Why can't I divide by anything I want?
Because it could cause something to not
You're right. We could. What? Rip the universe in half.
Yeah.
By what?
Dividing by 0.
Right. So we always have to have this. Do you know what I mean by a caveat? Have you ever heard that term? We always have to have a special disclaimer, right? You know, like if you take a look and slow down commercials, at the very end, in extremely small print, which the human eye cannot see, are disclaimers that say these were all professional actors. You can't buy this pickup with the real cool end gate unless you pay $35,000. Have you guys seen that, by the way? Okay. Chevy has a really cool end gate. It folds and does all this funky stuff. And then they have a backup camera. If you have a trailer, it makes it disappear. But again, that's only another $100,000. Okay? But that's in the real small print. Okay? The disclaimer. Here's this disclaimer. We use a semicolon and it says, hey, G can't equal 0, otherwise we're all dead. Okay? It can cause problems. Okay? All right? So you were getting there. You know, eventually you knew I was leading to the ripping of the universe, right? Alrighty. Now, polynomials that are, functions that are continuous at every point in their domain. So, polynomials. You guys know what polynomials are? Or are you a little bit nervous on polynomials? Allison, you a little nervous on polynomials? Okay. I'm going to give you some examples of polynomials. Is that okay? F of x equals 3. That's a polynomial. F of x equals 3x plus 3. That's a polynomial. Right? Constant, linear. We even give them names. 3x squared plus 3x plus 3. Right? It's a quadratic. The next one would be a cubic. The next one would be a quartic. Okay, and then I think it's a sextic. I'm not 100% sure. I've never gotten past the quartic. Okay? But you got the idea, right? So what we do is we say f of x. Here's our definition of a polynomial. We make it really ugly. We start out with a x to the n plus b x to the n minus 1 plus c to the x to the n minus 2 plus dot 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 once we get tired. And then at the very end, we say we got k, some type of constant. You know what I mean by polynomials now, right? And what's nice about those, Jack, you can put any number you want in there, and it's continuous. Because the domain, Denise, is all real numbers. Now, we do have trig. And we're okay with sine and cosine, but eventually we'll have something called tangent, right? Tangent has issues. Denise, Caitlin nodded that tangent has issues. Why did she nod? She nodded affirmative. It has issues. Do you know why? No? Can I ask you something?
Sure.
Okay, I'm going to ask you a different question. Are there two functions that I can divide to make tangent? Sine over cosine, correct?
Yep.
Okay. And so tangent comes from a division problem. Okay. Can be, what?
So the bottom can equal 0.
So, right. So that's why she said, at least I think so. Maybe she just doesn't like the word tangent. I don't know. Because it's associated with trigonometry. But it does have problems because you have division by 0, correct? So if you recall, this graph looks like this. This is the graph of tangent. Do you remember that?
Yep.
Okay. So do you remember what tangent looks like? You're okay here, there's a dot here, right?
And then it goes, all depending on which way it goes down on one side and then it goes up on the other. Yeah.
Have you ever seen the movie Saturday Night Fever with John Travolta? It'd be a good movie to watch. It was very, very popular. It had disco dancing on it. And John Travolta is really thin and young. And he wears a white suit. And he does this. In other words, I called it the tangent dance. And then my wife hit me. She wasn't my wife at the time. She was my girlfriend. She says, "You're such a nerd. Maybe I won't marry you." All right? But is it continuous between these asymptotes? Yeah. And these numbers are not part of the domain. 2 children aren't going to the birthday party. Is this the only place that it's not continuous? How do I write what intervals tangent is continuous? How do I do that? Do you guys remember learning about that? Let's just talk about this. I'm going to use interval notation, Justin. Okay? Do you know what angle measurement this asymptote's at? Yeah, because the cosine of pi over 2 is 0. Just like Denise said, right? I can't divide by 0. And so what's this one? Negative pi over 2. Perfect. Okay? So this interval of continuity is a negative pi over 2 comma pi over 2. Would everybody agree that that would be proper notation and that I would not use the brackets? Okay? So I am showing you. Now there's other ways you could do it and say n is an element of the integers and all this type of stuff. I'm showing you a different method. Okay, Ryan? I'm going to follow this by a comma. And I'm going to come up with another interval. And I'm going to put a comma here. So right here, I am going to have another asymptote. And this is going to replicate itself, correct? I think that's kind of what Denise was trying to tell me it looks like, right, Denise? So it has a span of pi. Would you agree? Pi over 2 is half a pi this way and half a pi this way. So what numbers need to be in here to represent that interval, Ryan? Will you say that again? Did you say pi? I didn't hear what you said. That's why I'm asking you. Okay, so it's going to start here at pi over 2, right? And then you said this is pi plus pi over 2. What's another way to say pi plus pi over 2? I agree. 1.5 pi. Can I write it as one complete fraction? You're doing wonderful, by the way. 3 pi over 2? Okay, 3 pi over 2. Perfect. Now I'm going to have a comma, and I'm going to write 3 dots. Do you know what those 3 dots mean, Ryan? Goes forever in that pattern. So I'm going to have 3 pi over 2 plus 5 pi over 2. Would you agree? And then I'm going to do this to the left. I'm going to have another set. And then I'm going to go dot, dot, dot. So what will these be? Negative what?
3 pi over 2 and
Negative pi over 2. Okay. Those are the infinite intervals in which tangent is continuous. Does everybody understand that? Is that making sense? Alrighty. Intermediate value theorem. Big, big, big. It is called the IVT, and you can use IVT as part of your explanation on the AP exam. Intermediate value theorem. It's based on this idea. Continuous. This is uber important, and we'll finish it tomorrow.